So you've built this amazing AI model, and now it lives in the cloud. Fantastic. But here's the billion-dollar question. Who holds the keys? I mean, think about it. Your data, your models, your entire infrastructure, it's all digital. There's no physical door you can just lock. This is where something called Identity and Access Management, or IAM, becomes maybe the most critical line of defense you have. And today, we are going to break down exactly how it all works.
Right. So if we can't use a physical key, we obviously need a system of digital ones. But it's so much more than just handing out a bunch of passwords. The real challenge, the real art, is creating a master key system that knows precisely who is allowed to do what and when they're allowed to do it. It's all about building a digital fortress of rules around your AI.
And in the world of cloud security, pretty much everything begins with policies. Before you can grant anyone access to anything, you have to write the rules of the game. You can think of these as the fundamental laws that are going to govern your entire AI environment. So, what even is this policy? Well, it's basically a digital contract. It's written in a format called JSON. Now, don't worry about the code just yet. The important thing to get is that this document lays out, in really clear terms, exactly what's allowed and what's not. It is the absolute heart of the entire IAM system. And here's the really cool part. This isn't just some abstract diagram. This is what the policy code actually looks like. And even if you're not a programmer, you can probably read it, right? It says the effect is to allow the action of getting an object, that's S3 get object, from a very specific resource. In this case, it's our storage location called My AI Dataset. See? It's simple, it's crystal clear, and it's incredibly powerful. So these JSON policies are super flexible. You can attach them to individual users, sure, but you can also attach them to entire groups and, as we'll see in a minute, to roles. This gives you almost surgical precision. You can grant access to a single file, or you can get even more specific and add conditions, like, I don't know, only allowing access during business hours? Look, if you remember just one thing about policies, make it this. They answer three super simple questions. Who is making the request? What action are they trying to perform? And on which resource are they trying to do it? Who, what, and which. That's the whole game. Okay, but you can probably see a problem here. Attaching these policies to every single person, one by one, I mean, that would be a complete nightmare, especially if you have a big team. It just doesn't scale. And that's exactly why we have our next concept, roles. This is where we stop thinking about individuals and we start thinking about jobs. This whole strategy is called role-based access control, or RBAC for short. And the core idea? It's brilliantly simple. You don't give permissions directly to a person. Instead, you create a role, like data scientist or marketing analyst. You attach all the necessary policies to that role, and then you just assign people to the role. And this table just illustrates it perfectly. Let's take a look. Ash has the marketing and the database admin roles, so she can access marketing materials and the databases. Makes sense. Brad, on the other hand, has the developer and database admin roles, so he gets access to the developer code and the databases. But here's the crucial part. Ash can't see the code, and Brad can't see the marketing stuff. Their access is neatly contained by their job functions. The benefits of doing it this way are just massive. This is how you manage access in a large, growing company without losing your mind. A new data scientist joins the team? Boom, you just assign them the data scientist role, and they instantly have all the access they need. Nothing more, nothing less. And when someone leaves, you just remove the role. It's clean, it's efficient, and it radically simplifies security. Now, roles are really powerful, but what if your access needs are even more complex? What if access should depend on the project, or maybe the sensitivity of the data, or the environment, like production versus development? For that, we need an even smarter system. And that brings us to Attribute-Based Access Control, or ABAC. With ABAC, we start using attributes, which are basically just tags. Think of them like little descriptive labels or sticky notes that you can attach to, well, to anything, your users, your AI models, your data sets. The system then makes access decisions on the fly using simple true-false logic. If the user's tags match the resources tags, access is granted. Here's a perfect example of how it works. A user assumes a role, and that role is tagged production. They try to access an AI model that is also tagged production. The policy behind the scenes simply asks, hey, does the user's tag match the resources tag? In this case, the answer is yes, so access is granted. It's a dynamic and an incredibly scalable way to manage permissions. So we have all these powerful tools, right? We have policies, we have roles, and we have this smart attribute-based access. But how do we use them effectively? Well, there's one golden rule, one guiding philosophy that should be behind every single decision you make, and it's called the principle of least privilege. This right here is the North Star of cloud security. The idea is so simple. Grant only the absolute bare minimum permissions and identity needs to do its job. Nothing more. Why? Because if an account ever gets compromised, and it happens, this principle dramatically shrinks what we call the blast radius. The attacker can only do what that one account could do, not bring down your entire system. So how do you actually do this? Honestly, it's a mindset shift. You have to start from a place of zero access and only add permissions as they are explicitly needed and justified. And critically, you should favor temporary access. Instead of giving someone a permanent key to the building, it's like letting them assume a role just for the time they need to complete a task. It's like a key that expires in an hour, which is so much more secure than a key that works forever. And all of this leaves us with a really critical question to ask ourselves. It's pretty easy to make our AI systems accessible. It's much, much harder to make them secure. Using the tools we've talked about, policies, roles, and that golden rule of least privilege, that's the only way to build a framework that is both powerful and protected. So take a hard look at your own systems. Are you just handing out keys to the front door, or have you actually built a secure lock?